In the previous video, we talked exclusively about whole numbers, numbers that don't have any decimal points. But how do we actually deal with floating point numbers? So in other words, if we want to use one or more decimal points. Well, in this video, we're going to make a start on figuring out how to do that in Java. So I'm going to create a new project in IntelliJ. Select Java as I normally do, and I'm going to create my project from the template, command line app, and I'm going to call this one float and double. I'm going to set the package name again. We will be talking about the base package and what this means a little bit later. For now, you can set that to whatever you like. I'm going to click finish. Okay, so how do we go about dealing with floating point numbers in Java? So that is numbers that have got a decimal point. So there's two data types in Java to deal with floating point numbers, and they are called the float and the double. And the float is a single precision and double is double precision, unsurprisingly given the name. So essentially the double data type has got twice as much detail as the float. So let's start with an example. I'm going to type some code in just so we can compare what a floating point number does compared to a whole number. So I'm going to create an integer variable type, call it my int value. I'm going to set that to the value of 5. Then I'm going to create a float, and to do a float you type in float, and we'll call it my float value equals 5. Now you can do that, but the proper practice for entering a float is to enter an F. Put an F after the number. Whatever the number is, you put an F at the end to denote that it is a float value. And because it is a single precision number, we can put a decimal point. So we could say 5.25 for argument's sake, because a float actually handles that precision for us automatically. But we're going to leave it as 5 for now. And let's create a double, and we'll call the double my double value equals 5. So we can do the same for that, and we can put a D, which is the proper way of defining a double, putting a D there to signify. But the other thing we can do is we can put the decimal point like so, 5.25, and Java will automatically assume that a number that you enter with a decimal point is a double. And this is very similar to what I showed in the previous video, where in an expression, the right-hand side of an expression, Java would assume the number was an integer. In this case, with a number with a decimal point, Java will assume it's a double. So we'll go back and set that to 5D again. So for example, I can't go back and do this, 5.4, because Java is saying required a float and it's found a double. Thinking back to the previous lesson, so here's a quick challenge for you. Thinking back to the previous lesson on how we used the cast to convert a byte and a short, how do you think you'd go about converting this value here, 5.4, to a float? Go ahead and pause the video and see if you can figure it out, and come back when you're finished, and I'll show you what the answer is. So how did you go with the challenge? Did you figure it out? Well, the cast, if you wanted to force the value, would be the word float in brackets, much like we used byte and short in the previous video. But I wouldn't generally recommend that. It would be far better normally to put an F on the end like so, because it's a little bit clearer in the code that that's what you want. But that is how you do it if you wanted to do it. But anyway, I'll change that back so that's also 5. So we've got 3 values now, an integer, a float, and a double, and they're all equal to 5. So let's go ahead and write some code. I'm going to print something out for each of them. So I'm going to type the abbreviation, SOUT, and press tab. And that creates that for us. It saves us typing a bit. And we're going to put my int value equals plus my int value. I'm going to type SOUT again and put my float value equals my float value, and my double value equals plus my double value. So probably won't be surprised when we run this to see what the result we'll get. And I'll just double click that, and we'll run it again. And you can see here to the right hand side, the values that my integer value was 5, but notice how the float value and the double value have got a 0.0 on the end of it. So it's actually stored it as 5.0, and that's because it's a floating point number. So that's all well and good. But what do you think will happen if we change this and put 5 divided by 2? So let's just run the first one first, just to see what the integer value will come back as. Bearing in mind it's a whole number. So you can see what's happened there. We've tried to divide a whole number 5 by 2, and the answer is 2. And that's because it hasn't taken into account the remainder. It's literally just said 2 goes into 5 only 2 times. So we're not handling any remainder in that case. But let's go back and do the same thing. And we'll divide the floating value by 2f. So divide the floating point value of 5 by the floating point value of 2f. And likewise for the double, we're going to divide that by 2d. So let's just see what gets returned when we do that. So that should hopefully now clarify the difference with the data types. You can see that the float and the double both give you the exact value, in this case 2.5, and because the integer value is a whole number, it's not retaining any remainders, whereas the float and the double is giving us the complete answer, the correct answer. And just to be sure that that is working, we could divide that by, so let's just divide that by 3. Run that again. Now as you can see, the first one integer, there was only 3 goes into 5 only once, so it returned once. So a float has 7 decimal digits of precision, so that's numbers after the decimal point, and a double in fact has 16 digits of precision after the decimal point. So you can see that the double value is far more precise. And also, as I showed you before, the default value for a decimal point, if you don't specify the F or the D, is actually double. And that's another hint from Java that it recommends that we use doubles. So in terms of space, a float, you remember we talked about this in the previous video, the width of an integer equals 32, which effectively is 4 bytes. A float has got a width of 32 as well, which is equivalent to 4 bytes. Can you guess what the double will be? The width of a double equals 64, which takes up 8 bytes. So a double takes up twice the amount of memory that a float does, but with that said, there's still really compelling reasons to use a double whenever you're using a floating point number in Java. First reason is that double precision, which is the use of a double data type, is actually faster on many modern computers. And secondly, many inbuilt functions in Java, math functions that like sin and cos and so forth, they actually use doubles as their calculations, and you can understand why they want to do that because it's more precise, there's more digits of precision. So that's really 3 reasons why you'd want to use it. The fact that the double is actually faster on modern computers. Also, the inbuilt functions in Java usually use a double. And thirdly, the double is far more precise. So it's actually, as you can see there, 16 units of precision compared to just 7. For that reason, I recommend using doubles. And from this point on in the course, I'm only going to be using doubles for mathematical calculations. So it's now time for another challenge. So the challenge is as follows. So here is the challenge. Convert a given number of pounds to kilograms. So the steps to take will be to create a variable to store the number of pounds. Secondly, you need to calculate the number of kilograms for the number entered above, and you need to store that in another variable. Thirdly, then print out the result using the system.out.println. And there's a note there that should help you a lot to figure out the conversion. The 1 pound is equal to 0.45359237 kilograms. So go ahead and try that now. Pause the video, see if you can figure that out. Come back when you're finished and start the video again, and I'll show you my solution. So how did you go? Did you figure it out? Let's make a start on it. So step 1, we need to create a variable to store the number of pounds. I'm going to call that double num pounds. And I'm going to make that equal to 200. 200D, so it's 200 pounds. Next, we need to calculate the number of kilograms for the number of pounds. in this case 200, and store it in a variable. So we're going to do another one. We're going to put double, we'll call it converted kilograms equals. So our hint is that 1 pound is equal to 0.45359237 of a kilogram. So how would we go about that? Well, it's actually pretty straightforward. All we need to do is multiply the number of pounds by 0.45359237. Now you want to put a D on the end there just again to tell Java that this is a double, even though it would default to it anyway, but just to be clear. So we've now got our converted kilograms, and then we do a sysout kilograms equals plus converted kilograms. So now if we run that, we can see that the kilograms is 90.718474. So let's check that now with Google. So we can easily do that. So we can go to Google, and that will actually tell us the answer. So 200 pounds is 90.7185. I'll just take a copy of that. So we go back to IntelliJ, and that was the result. 90.7185. In our case is 90.7184, but it's 847, so rounded up that would be 90.7185. So therefore our calculation is correct. So that's how you go about converting pounds to kilograms. And that in a nutshell is the float and the double for dealing with single and double precision numbers in Java. And just one last thing now, just to finish off. You remember in the previous video, we were able to use underscores when defining a literal value. So a literal value for a float or a double can be done the same way. So we could, for example, put double pi equals, now we could put 3.1415927 like so, or with a D to make it precise. But we could also put, if we wanted to, 141. So we could put numbers, define numbers like that with underscores if we wanted to make it clearer, or we of course can also put them before the decimal point. For example, 3 million. So in that case, the answer, the pi would be incorrectly specified as 3,000,000.1415927. So just wanted to make a point that you can use underscores to make your variables cleaner when you are setting a value as a literal. So that's it. We're now done with floats and doubles. In the next video, we're going to have a look at two other data types, namely the char and the Boolean. I'll see you in that video.